determinants. Exercise 4.6. Solve system of linear equations using matrix method. Question number 9. 4x minus 3y is equals to 3. 3x minus 5y is equals to 7. So we have to solve these two system of linear equations in the matrix method. So let us see the solution. So first we write the system of linear equations in the matrix form, that is Ax is equals to B, where A is the coefficient matrix containing the coefficients, that is 4 minus 3, 3 minus 5, and x is the column matrix containing the variables. Here the variables are x and y. And B is the again column matrix containing the constants in the right hand side of the equation, that is 3 and 7. Now let us check whether the matrix A is singular or non-singular. So consider the determinant of A. Determinant of A is equals to determinant of 4 minus 3, 3 minus 5. So that is equals to 4 into minus 5. If you expand the determinant, so we get 4 into minus 5 minus 3 into 3. On simplifying, 4 into minus 5 becomes minus 20 minus 3 into 3 becomes minus 9. So that is equals to minus 20 minus into minus plus 9. So minus 20 plus 9, that is minus 11, which is not equals to 0. So determinant of A is not equals to 0. So A is non-singular matrix. So A is a non-singular matrix since determinant of A is not equals to 0. Then, so since A is non-singular, A inverse will exist. Now let us compute the inverse of A. So that is A inverse is equals to 1 by determinant of A into adjoint of A. So already we obtained the value of determinant of A, that is minus 11. So let us compute adjoint of A. To find the adjoint of A, we need to find cofactor matrix. So here the given matrix A is 4 minus 3, 3 5. So now compute the cofactors. Here A11 means first element in the first row, that is 4. Then minor of A11 is denoted by M11. So minor for the second order matrix is diagonally opposite element. Here for 4, the minor is -5 and its cofactor is denoted by capital letter A11. So here if you see the sum of the suffixes, that is 1 plus 1, 2. So that is even number, and the sum of the suffix is even. So minor and cofactor will be same. So A11 value becomes -5. Next element A12. A12 means second element in the first row, that is -3. Then minor of A12 is denoted by M12. So diagonally opposite element for -3 is 3. And its cofactor A12. Again sum of the suffix is odd, that is 1 plus 2 becomes 3, which is odd. So cofactor will be negative of the minor. So A12 value becomes -3. Next this element, that is A21. A21 means first element in the second row, that is 3. Its minor M21 is equals to diagonally opposite element for 3 is -3, and its cofactor A21. Here sum of the suffix 2 plus 1, 3, which is odd. So cofactor will be negative of the minor. So negative of -3 becomes 3. So next A22, that is second element in the second row, -5. Its minor M22 is equals to diagonally opposite element for -5 is 4. And cofactor A22 is equals to, the sum of the suffix 2 plus 2 is 4, even number. So cofactor and minor will be same. So that is 4. So therefore adjoint of A is equals to transpose of the cofactor matrix. That cofactor, if you write the cofactors A11, so that is -5. Here A12, that is -3. A21, that is 3. A22, 4. Its transpose. So that is equals to, transpose means you have to interchange rows and columns. So write first row as first column. So first column becomes -5, -3. Second row as second column. So that is 3, 4. So this is the adjoint of the coefficient matrix A. So if you substitute the value of determinant of A as well as adjoint of A in A inverse, so we get the value of A inverse as 1 by determinant of A is minus 11 as well as adjoint of A. We are substituting adjoint of A, which we calculated in previous step. So now the solution, we know that solution x is equals to A inverse into B. So that is x means the column matrix xy, that is equals to A inverse. A inverse is 1 by minus 11. So we can write minus 1 by 11 into minus 5, 3, minus 3, 4 into B. B is the column matrix containing 3 and 7. So that is equals to minus 1 by 11. If you multiply these two matrices, so if you multiply first row and first column, corresponding elements of first row with first column, so we get minus 5 into 3 plus 3 into 7. Again, second row with first column, so minus 3 into 3 plus 4 into 7. So that is equals to minus 1 by 11. If you simplify, minus 5 into 3 becomes minus 15 plus 21. So that is minus 15 plus 21 becomes 6. Here minus 9 plus 28, that is 19. Or if you multiply this matrix by the scalar quantity minus 1 by 11, so we get minus 6 by 11 as well as minus 19 by 11. So this is the value of x and y. So if you equate these two matrices, so we get the value of x. X is equals to minus 6 by 11 and y is equals to minus 19 by 11. So this is the required solution. Thank you. Have a nice day.